Hello guys, I am Sohan and let's start from where I left the last day, and from this NAND gate we'll build. Today we'll learn the circuits of OR gate, NOR gate and XOR gate. So this is a NAND gate. Let's see how it works. When I turn this one off, then this transistor right here, this one turns off this line, and when I turn this one off, then this transistor turns this lane off. When both of them are off, then obviously anyone is doing this job, but this is a NAND gate. So for a NOR gate, for a OR gate, I have to change the behavior. Let's stop the simulation and connect the emitter to emitter. Previously connected collector to emitter. Now we are connecting emitter to emitter and collector to collector. Now what happens? Also I'll have to move this one here. Now what happens when I turn this one off? This transistor is off, but this transistor is conducting, and when I turn this one on, this transistor is off, but this transistor is conducting. When I turn both of them, that is when I get the off signal. And if for a NOR gate, I just have to connect outside here, and this is the NOT gate. This is the only state where this light is on, and everywhere else it is off. Now that previous OR gate that we have saw, this one does not really work for all purposes, because this is pretty much, this does behave like a OR gate, but this is not really a gate, because we have to connect whatever component within this. We cannot transfer this to a different circuit and then again get its response back, because this ground, this is the ground. For this input, this has to be the ground state, but it does not really reference to this ground. So if you didn't understand, just understand that this creates a problem. So we now have to take this NOR output and pass it through a NOT gate. So if you have watched the last video, you can understand how a NOT gate is built. Just have to connect the ground here and a resistor of 200 ohms. Now this segment right here gives us the OR state. Let's connect to the ground, and this is the OR. When either of them is on, this then this is a pretty much OR gate. When both of them are off, only then this light turns off. So we have the OR output right here. So we have learned NOR and OR gate so far. Now let's look at the XOR gate. XOR gate is a little bit complicated, because when it works only when this the inputs are in alternating state, because if this is 1, this is 0, it works. If this is 0, this is 1, it works. If both of them are 0, does not work. If both of them are 1, it does not work. XOR is by definition like this. XOR is by definition behaves like a OR gate, but not an AND gate, an OR gate but not a AND gate, a OR gate, which is this one, and a NAND gate, and NAND. Let's look at the NAND gate first. So we have, you know how the NAND gate looks like. So this is how the NAND gate looks like. This is how the NAND gate looks like, but we have to connect this. So first we need to connect the power with a 200 ohm resistor. And we have to connect this input to this one with through a resistor of 10K, and we have to connect this input through a register of 10k. Now this here gives us the OR output, sorry, NAND output. Let's convert this to a green LED. Now this one will give us the OR state, this one will give us the NAND state. Now let's look at this. Let's start the simulation, and when both of them are on, this is off. When both of them are off, this is off and this is on. When either of them are on, both of them works. So you have seen this. Now we just have to use these two circuits in a single circuit, combine them to form a single output. We have to take these two inputs and form them to a single output. Let's connect this to a transistor, connect this to a transistor. We are basically making another NAND gate. Now if we connect the load here, we should get the XOR output here. Connect the ground here. This is an AND gate in the, as from the previous video. When both of them are in same state, this one turns off. When they are in alternating state, this one turns on. Again you have a small problem here. This one is within the circuit. We need something outside the circuit. So you have to take this output and feed it to a transistor through a resistance of 200 ohm. I also have to take this down a little bit. Connect the LED here, and now it will work in respect to the ground. Alternating state on, same state off. Alternating state on, same state off. If I have to use it though, you can use it through an LED here. Through an LED here. Now we can see the outputs live. You can see how this trigger this LEDs, and this LED is combined to output this LED. Let's change the color of this one to yellow and this one to sky blue, and together this LED forms. So hope you found this interesting. Thank you.